Hello everyone. Today we are starting our session 5 of the Android Study Jams, and today we will be starting to learn about coroutines and internet. I'm Tanmoy there, and I'll be hosting it for you guys. Um, did anybody try to join or something? Reserve to host है ना?
Yes.
तो
Yeah,
join
I'm
कर
used to that. You
allow
only
कर देना.
focus on the presentation.
Yeah. So what we'll be learning today are coroutines, what is HTTP and the REST web framework, how to get data from the internet and load in the app, and in details we'll be learning why coroutines are preferred over the threads and how HTTP works better, how internet connections happen, and overall. So for this, the curriculum used would be the official developer courses pathway which you have been learning till now. And the prerequisites for doing this class would be the previous concepts which you have been learning in the previous sessions, and you also need to complete the previous pathways. So let's get started on this. So by default, we have been doing a lot of Android applications till now, from pathway 1, 2, and 3, and 4. However, in all of those, we were using the same thread, which is our main thread. So everything which we were running in the code was working through the main thread. However, since all those applications are single-threaded, the main thread could perform the duties of it very easily. And that is why we didn't need to think about concurrency and other stuff. However, sometimes we need a multi-threaded approach. Now you might be wondering, where all do we need multi-threaded approach? So we need multi-threaded approach for stuff like if you need to perform a network operation, a heavy logical operation. Now, if we perform a heavy network operation, the app might get laggy, it might freeze the UI interface. Now, overall, we wouldn't like the user to have a UI interface which is buggy, right? So we need to make sure that in these cases, we have a multi-threaded approach because in that way, the main thread can't get freezed while the app is running. So before I tell you about threads and coroutines, it is important that you understand what concurrency is. Now, concurrency allows multiple units of code to execute out of order or in parallel. Now, to put in layman terms, it's like almost simple to if you're walking on the road and you're also listening to music at the same time, or if you're cooking something and watching a video, you're performing multiple tasks at the same time, right? Concurrency basically stands for that. Now, why do we need to use concurrency like I explained in the previous slide? As the app gets more complex, it's important for the code to not block other aspects of the app from each other. So this is why we make sure that we use concurrency. What are threads? A thread is like the simplest unit of a code. Now we won't be using threads, we will be actually using coroutines, but it's important you know why we can't be using threads. A thread is like the simplest unit of code that is scheduled and runs in the confines of the program. Now here is a snippet which shows the basic outline of how a thread works. We need to declare it using the thread object, which prints like thread.currentThread, which accesses the thread on which it is running. And we also need to call the thread using the .start function. Now why we can't use thread? I'll be further explaining using a live demo what is the problems with threads and why which coroutines are preferred. So just like follow it from the PPT right now, and later on I'll show you the live one. Why threads aren't suitable? Firstly, it requires a lot of resources. Like every time if you need to create a thread, it takes up the system resources, it limits the time the number of threads can be managed at the same time, and overall it makes it very intensive for the device to run a lot of threads. So the cost of creation adds up. Race conditions. In race conditions, what happens is if two threads try to access the same value in the memory, at the same time, so it is like very hard to reproduce if you want like if, because of course it will produce a bug, right, if two threads are trying to access the same thing. But however, when the bug which is produced would be very hard to reproduce if you try to debug it. So this is why race conditions aren't preferable. So threads aren't suitable because of the race conditions which it provides. Unpredictable behavior. Now, while I'll give you the live demo, you'll understand that when threads run, it doesn't run in order as you expect it to be. Like different sets of instructions on different threads runs at the times when it's more suitable to them. It doesn't order like run accordingly as in order it's supposed to. So this is why threads aren't suitable. Coroutines. Now, Kotlin, this is why Kotlin actually doesn't use threads for the codes which needs to block and stuff. So it uses coroutines. What are coroutines? I'll be explaining now further. Coroutines. Now, like officially, the description of coroutines is lightweight threads, but by lightweight, it means that creating coroutines doesn't allocate new threads, right? It instead uses the thread pools which already exist and uses it using smart scheduling like launch, async, and await, and then it executes the task. The main advantages of coroutines would be it has built-in cancellation support, like you don't need to worry about like race conditions and memory leaks. There's actually low chances for memory leaks, and there's Jetpack libraries which provide us with coroutine support. In the later part of the today's session, which you'll be learning how to connect to the internet, you'll see that we are using some libraries, third-party libraries, open source of course, like Retrofit. These libraries provide coroutine support, and hence it's easier to use coroutines. Now, before we start using coroutines, there are some stuff which we need to understand very well. So the first thing is suspend. It's a keyword which is used for functions. It's added like the snippet of the code suspend func sample, and it although it sounds like blocking, but it doesn't work like blocking. Like if it was a blocking, you would be stopping the code from running any further. However, in suspending, it just pauses it and resumes it later on. And the thing about suspend function, which you guys would be knowing, is like if you want to call a suspend function, it's only called within another suspend function. All right. And the second part is a job. A job is like a cancelable unit of work. We can put the entire coroutine life scope within a job. So like a job exists as long as the coroutine exists. And as soon as the coroutine is cancelled or is completed, the job's work is finished. We also pass a job within a coroutine scope to manage the life cycle. Now these are the most important thing about coroutines which you guys should understand. These are dispatchers. These determine the thread which the coroutine would be using. Now mainly there are of three types, which is dispatchers.main, .default, and .io. Now dispatchers are very important because we need to use the correct dispatcher while running our code. So like if you are running a code which is updating the UI, we need to make sure it's always running on the main dispatcher. However, if there's a code which is like doing a network call, which is going to take a lot of time, we need to make sure it doesn't run on the main thread because, like I said before, it would be glitching the app and making it buggy and laggy. Like that, we have dispatchers.default. So when you explicitly don't mention any other dispatchers, the coroutine dispatcher, which is used by the builders, like launch and async, which I'll be showing further on, use the dispatchers.default version. And then we have dispatchers.io, which is like input output tasks. It's for offloading and blocking. This is basically used for network operations. So like which are lengthy tasks, like you can understand, we can't run it in the main thread, otherwise it would make the app laggy. Like UI interface would become slow. So we need to use it in a different threads, and that is why we called it the dispatchers.io. Creating coroutines. Now, there are literally three builders for creating coroutines. Like when you'll be going through the pathway, you'll further see over there also. The first one we use is launch. It launches a new coroutine, and this launch function is different from the other functions in the sense that it doesn't block the main thread. Like if you execute the code from launch, it does not wait for the job like cancel. Instead, it's just wait and it then produces the result. But the result is like it's not like it produces any result like it returns or something, but it just does. So basically it's saying like launch doesn't wait for any results. It just gets cancelled when the resulting job is cancelled. Async. Now this is something which you guys need to understand a bit better because async blocks the main thread, and that is the main difference of async with launch. While with launch I told you that it doesn't block the main thread and simply just finishes the task, whereas async blocks the main thread and not only blocks the main thread, it also returns. It returns a type called deferred. Now deferred is like it's a promise that it's going to return a value over there. And we can't use async in a normal function. So we need to also call a suspend function called await, which gets the result from the async function. Now, unless the main thread is blocked, we need the main thread to be blocked and stuff. We don't normally use launch. However, we generally use async when we need parallel execution of tasks. So like if the basic example would be if you have two networking calls which need to be run parallelly, so then we need to do a async function call, and that way we can get the networking results and only then further do our further operations on the app. This is a code snippet of how async works, and I'll be showing it to you in live. Run blocking. Now the thing you need to know about run blocking, it is not normally used in Android code firstly, and Other than that, like the name is pretty self-explanatory. It pretty basically blocks the current thread on which it is being invoked until the coroutine is completed. So like if the coroutine is working on a thread and it's invoked and then a new coroutine is started, then as long as the coroutine's work is not finished, it blocks the current thread until completion. So like if you have two types of codes, like which is one is blocking the threads and one is non-blocking the threads, we normally use run blocking in between to make sure that both the codes are joined together. And it's basically using tests, but you wouldn't find it in day-to-day app development codes and stuff. Now we'll move on to the second part, which is displaying data over the internet with HTTP and REST. Does anybody have any doubts regarding coroutines? No doubts. All right. So the first thing that you need to know about this is how HTTP works. Like from daily users, you might have understood like regarding how we connect with a server and client is suppose if you're searching for something in the Google or like if you're searching something in any social media app, or it doesn't have to be any such thing. It could be something small like you're fetching data from like most of you are from KIIT students, right? So if you're fetching some data from the KIIT app and stuff, so this is what happens. We send a request and then the server processes it and then it responds to us. So we are basically the clients and the server is the one from which we are asking the request. Now, if you have seen above URLs which are at the top of the search engines, you might have seen HTTP and all those stuff written. So it's basically a protocol. I'm pretty sure you guys might have learned it before also. Hypertext Transfer Protocol is called. And this is the basic way in which a client communicates with the server. Now, this is a typical example of how a HTTP request is. Now, we don't get to see the insider headers and stuff, but this is what happens totally inside. So if you're searching for something, we use the get method. And I'll be further explaining what the different kinds of methods available to us and stuff. So for example, if we take into account this HTTP request, since we are asking for, we are fetching data, right? So we are using the get method over here. After that, we have put in a query, which is Android, which is at the end of Q equals to Android there. Then we have a HTTP version 1.1, and the server from which it is getting the HTTP request is google.com. Now there are other headers also like cache control, accept language and stuff. But these headers are not very important. These headers are the basic stuff which your client needs to send to the server in order to get the proper responses. All right. So this is basically the outline of how an HTTP request works. Now, like I was saying, it was about get. So these are the HTTP methods which are available to us: get, head, post, put, and delete. So get, like I told you, if you're fetching some data, like you're searching something in the online stuff and places, so the get method is used. It retrieves the information. If we only need to get the headers of the stuff, like I showed you in the previous two slides over here, cache control and accept language. So these are received using the head method. And it basically just retrieves the resource headers. Then we have post, which submits data to the server. Like if you need to submit any kind of thing, like let's suppose you're using a social media app and you're posting a picture. So that is when the post method comes into play. You're posting it using the HTTP method called post. And put, if you need to save the object at the location, then we are using the put method. And then comes the delete method. The delete method is basically self-explanatory because we're just deleting the object at the location. In our day-to-day lives, we are using these HTTP methods everywhere. Like every time you make a Google search or any query, if you have, you make any kind of search, even in different web searches and search engines, you're using the get method. And when you're using any kind of interactive apps where you're submitting the data to the server, right? So then we are using post method. And then if you're deleting that stuff and all, we're using the delete method. That method is normally not used like us developers unless it's like for we need to know the basics of how it's working and stuff. So we also then retrieve the resource headers. HTTP status codes. Now the methods, like I showed you in the first diagram, the client sends a request to the server and then the server responds to it. But while the server responds to it, it responds using status codes. Like other than the response, it also returns a status code which tells us about if the response was successful or not, right? Like we need to know if the response worked properly as should have. So this is where the status codes comes into play. Now the common status codes which you might have always heard like error 404, right? we get it when there's a client error. So like that, there are a range of status codes, which like any status code which begins with 1 is for informational purposes. If a status code begins with 2, it is a variation of success. Like if you get a JSON response, it returns as the success response code is 200, but there are like other success response codes also which fall within 200 to 299. Like I told you about error 404, it falls between 400 to 499, and it's a client error. You might have always seen like page not found, error 404 like that. And then there's 500, which is a server error. So like remember a few days back when we had the entire internet, few websites had been crashing and we couldn't be accessing like WhatsApp, Facebook and stuff. So it was an internal server error. You might have seen in some places 505 and stuff for the server errors. And then there's 300, which is not like a common HTTP status code, but anything which begins with 3 is used for redirection. Suppose uh, we log into a web page and then the web page redirects us to some different web page. So then it returns the status codes of redirection. So basically these 5 are the status codes available for HTTP responses. However, the most common ones, as I said before, is 200 to 299, which is for any kind of success responses, 400 to 499, which is for client errors, and 500 to 599, which is for server errors. REST. Now, this is like the most important thing which you should know about today's class, how REST works. REST basically stands for Representational State Transfer. Now, in layman terms, REST describes a simple interface that transmits data over a standardized interface, like such as HTTP or HTTPS, without additional any messaging layers. So this is like the most basic description of REST which I can give you. Now, it's like an architectural style. It is not exactly like a web framework and stuff. It is followed, and that's how it's working. So basically, what happens if you use a REST framework is suppose a client is accessing some kind of data, and so it accesses it using a URI. URI is almost like a URL, which you might have been seeing. So URI stands for Unique Resource Identifiers, and it's a standardized fixed set of methods, and the representation of resources is returned from the REST framework. Now, how it works is like, let's say, suppose you're searching for something. So let's say you're going to a profile picture in your Facebook account. So it goes like www.facebook.com, which is of course a server, and then we have the slashes, and then we have profile, and then photos. So like photos is the endpoint, and the photos is acts as a URI, the entire fucking URL. It acts as a URI. So what are the different reasons why which REST is preferred is it is a client-server architecture, resources exposed as URIs, uniform interface, and stateless. Now to explain those stuff is client-server architecture. It separates the client and the servers into interface requirements and data storage requirements. It improves portability of like the user interface across all multiple platforms. Like you could be accessing it from a phone, you could be accessing it from a laptop or like a computer and stuff and all. It makes sure that from any kind of way you're accessing it, the responses are always the same. Then we have resources exposed as URIs. URIs, like I explained to you, are unique resource identifiers, and it enables accessing a response using the methods, HTTP methods like get, post, put. So these are the methods which help us in accessing the resources which are in the form of URIs. Uniform interface. Now, uniform interface is the like I told you in the before for the client and server architecture. Like we have the same method of accessing throughout the places in any kind of web, laptop or like phone or device. You access the server, you get the uniform response, and that also through the same methods of get, post, put. Stateless. We use a stateless communication transfer method like HTTP, and all the requests contain all the information needed. So like if your client is asking for some information from the server, it makes sure it passes all the headers which are required for it to return, and this session state is stored only in the client side. So that way it makes it less intensive, and this is why REST is preferred overall. Now the web services which are built on REST framework, so it's called RESTful web services. So like in today's Android app, when we be connecting to the internet, we'll be seeing that we are using RESTful web service for connecting to the API, and how it's preferred. We are actually using a third-party library called Retrofit to display that, and that is how a REST or like representational state transfer works. So we move on to the next slide. Like I was telling you about retrofit, so we were using a retrofit library, which will be used for connecting to the backend. It creates our URIs. Like I said, if you want to access your photos, so like photos access the endpoint, right? Like after the server name, the photos access the endpoint. So retrofit makes sure that it creates the URIs for web service based on the parameters you pass to it. Sometimes there may be more than one parameters. Like in search queries, you might have seen like there's Android and then there's some places UTM which passes our device information and stuff. So these are all the different kinds of parameters which are sometimes required. JSON. I added this part because there are a lot of first year students who are learning, and I'm not expecting them to know what JSON is. But I hope you might have heard of JavaScript languages and stuff. So like JSON is like JavaScript object notation, and it's a text-based format. Like we use the XML format in our coding in the Android Studio. You might have seen .xml files like manifest.xml and stuff. So like that, there's JSON.json files and stuff, which is used for displaying the data in the form of JavaScript object syntax. It is like one of the most used method of transmitting data in web applications. And if you see down the image, it shows like how the JSON array is passed. Like inside the JSON array, there are a lot of JSON objects, and the first part, which is before the colon, are the keys, and then the values are mapped to the keys. So this is the example of a sample JSON response which you receive. And then we have Mosi. It's a JSON parser. Like when we get a JSON response, we can't directly use it inside our code, right? Because it would be in the form of JSON object syntax. So we need to make sure that we convert it into a Kotlin object. Now, retrofit does the work of connecting to the backend library, but we need a different library which will convert the JSON string into the Kotlin objects. And this is where we use the Mosi. It's a great library which is used for the purposes of converting the JSON strings into the Kotlin objects, and it actually is built in, works pretty nicely with the retrofit, and it creates the URIs for the web service along with the retrofit library. Exception handling. Now, exception handling is the stuff which will be actually, it's not important for connecting to the internet, but we need to know it in some cases when our program code might run into like problem situations. Like suppose you are connecting to the internet, but in your phone the internet is off, or like if your phone is on airplane mode, so we can't have our app like crashing at that point, right? We need to make sure that we handle it. Like if the internet is off, then it needs to display a proper message that the internet is off. Or let's say if it's accessing some data from a server, and the server is not being able to produce the data at this point, like the data access is denied. So we need to make sure that we display appropriate message to the user, and so that the app doesn't crash in the event of unexpected situations, right? So exception handling is normally used using the try catch block. So within the try part, we write the code which can throw the exception. Like if you want to connect to the internet, we write the code about connecting to the internet, and the catch part catches the exception. Like if the internet is not found, or if the permission hasn't been given to the user yet for connecting to the internet. So in the catch, we make sure that we take care of the situations when if the internet is not provided, and this, like display the appropriate messages to the user. You might have used exception handling before, but we'll not be actually needing it for connecting to the internet part. But if we want to make sure that our app is properly made, so this is the situations when we make sure that exception handling works. And it's not just a specific term of Kotlin, it exists in all the languages. And so it just prevents runtime crashes and handles the errors. Now I'll give you the live demo of the coroutine part, and then I'll explain to you how the connecting to the internet part works. Does anybody have any questions? Anybody has any questions? Okay. So like I was telling you then, uh, just like a boilerplate, you can just start any activity. All right. So there's nothing like that. I'll be just running a few Kotlin files to show why threads and coroutines work differently. Like just put some name like thread.kt, and then we need to write a main function to run the code. Obviously, you guys might have learned that by now. And let's say a variable count equal to 0. It's used as a var because if you use a val, then we can't update the values in count. Like these are basic Kotlin stuffs which you might have learned somewhere. So if you run a for loop for I and And then like I was showing in the snippet of the threads how a thread is begun, right? So we need to write thread, and then we need to give third column brackets, and then we need to write the operation which we want to be processed inside the thread. So like count plus equal to 1. And if we need to put a print statement, otherwise you would need to check it from the log cat how it's working. Excuse me. Thread. So what this part of the code is doing is we are printing the thread number, like we are running the loop from 1 to 50, right? So by basic computer terms, you might have known by now that it's supposed to run like thread 1, and then since the count is incrementing before the print statement, so it's like thread 1 count 1, then it's again repeating like thread 2 count 2, like that, right? However, you guys will be surprised to see how it works. We need to also add the start function, like I told you, and this is how basically threads work. And now you see how I was telling you that why threads aren't suitable, and like yeah, see. So basically, the first time the print should have been thread one count one, right? However, like the first time we got thread one count five, and after it should be like thread two because that's how a loop is running, right? From one, two, three, four, and you know how this works, right? With the dollar signs and I is basically just asking us to put the value of I and not the variable name. Similarly here, count, it's asking us to put the value of the count. So first it's like thread 1 count 5, thread 9 count 40, thread 7. So it's all coming haphazardly. So it's like totally unpredictable, even though it's supposed to work like thread 1, thread 2, thread 3, like that, right? So see, like it's totally unpredictable, and this is why we can't use threads. So this is why Kotlin implemented the coroutines, because we can't have codes which run like so unpredictably. So I'll just show you how coroutines work then. For the coroutines, if you're just running a Kotlin code, so you just need to import the Kotlin x.coroutines.star. Star basically includes everything which is inside the coroutines file. Alright. So once again, we need to write a main function and repeat. It's basically like for loop works. It's just gonna repeat the code. And I showed you run blocking, how run blocking works, right? So we need to like call run blocking and then launch. We're calling launch inside the run blocking because we don't want to put a async function call here over here. I'll be showing you later how we can do it with async function calls also. So let's say we want to print the thread name. Hi from and we'll call the thread current thread. So this is a sample code. It's supposed to call the current thread, but this time we are not using threads, we are using coroutines. So if we run it, see, so this all of these are working on the main thread. Since I will not specifically explicitly mention anything, so it's all working on the main thread. I should be using some kind of this snippet of code in the Android app and stuff. Then we need to specify that what it would run on. But like there's other dispatchers which I was talking about. So if I specifically mention dispatchers dot, see over here you can see IO default main and unconfined. IO if I mention it as IO, and then if I run it. See, this is how it works, and this is the default dispatcher it's working on. Alright, so now I'll just show you how to convert a code which is already in threads into coroutines. Okay, so I'll just remove this entire part and say function main, and we'll just take an array over here and so that I can show you exactly how differently it's working. Like I'll just replacing the thread code over here with the coroutines. Like I'll add some simple values like starting and doing task 1, doing task 2. This is not important. I'll just show you like how haphazardly it would work with threads and how in order it would be working with the coroutine. Like, ending. Like I was doing the last time with repeat 3, and then we need to begin our thread, so we're calling the thread function. Thread, and then a print statement like the thread is being started. Thread dot current thread, since we need to call the current thread on which the code is being run, and we need to specifically mention that current thread has started. For if we are looping through the entire array of within the for I in stage, and it's showing some kind of error, which is for using brackets. Okay, there's a third bracket is with you. Yeah, it's works perfectly now. Thread, thread, and something extra. Yep, the for I in state and print error. So we'll just loop through the starting, doing task 1, doing task 2, and ending, and we're repeating it 3 times, so that like 3 threads which will be getting started, and it will be repeating starting, doing task 1, doing task 2, doing task, and then ending. Right. However, you guys could see that it wouldn't work that way with threads. So thread, thread, and I'll just display that on which thread, which part of the array is working. I need to make sure that the brackets are closed over here. Yep. Perfect. Again, extra bracket over here, and then close the main bracket. Yep. So if you run this, this is for the threads. All right. I've just kept the import coroutine, but you can see it's blank, so it's not printing anything other than that. All right. So this is for threads, and like it's supposed to print other than the stuff. Okay, I think the main threads are not working over here, so I'll just show you with the coroutines part. For the coroutines, we just need to add, instead of threads over here, we just remove the thread, and then we have run blocking and launch. And we need to make sure the entire code is inside launch. And yeah, so like all the brackets are closed over here. Oh, we need to have another bracket for the launch. Let me perfect. We're running. Yeah, see over here, first it's starting with the main 5 main, and then it's finishing with starting, then like doing task 1, doing task 2, and ending it. So I just added a bracket here, so it's been printed extra. Anyways, so after that we are starting the other thread, and then we are starting doing the tasks and ending it. And similarly, however, in the case of threads, this wouldn't be the same. We'd actually be getting output, like I was saying in the first thread, we'll be getting output like thread main 5 doing task 1, and then there'll be like thread main 5 doing task 2, and then we'll be starting again and ending. So it would be in a haphazard manner. But coroutines run blocking makes sure that when one coroutine is getting started, it makes sure that the entire coroutine is finished, like from starting, doing task 1, doing task 2, and ending it, and only then it's moving on to the next thread, right? However, in threads it wasn't working. So this is it. Like, does anybody have any doubts regarding this? Or then I'll move on to the connecting to the internet part. the file. And, hello, sorry, my network connection was disturbing, so I got disconnected. Could anyone tell me like till where I had studied, like where I had started? Lisa?
You were just opening the new project and it got disconnected.
Okay, okay. All right. I'm so sorry for the inconvenience. Like my network got disturbed. So I need to begin it from the before. Like I didn't explain this stuff, right? Rishabh?
You aren't presenting your screen, please start presenting.
Okay, one second. Yeah, I didn't start explaining this codes, right?
No.
I finished the coroutine part, right?
Yeah, yeah.
Hello. Okay, so here we'll be accessing the internet and we'll be displaying Mars data. In case I get disconnected, just let me know. So, listen, uh, over here we'll be accessing the Mars backend server and we'll be getting the images. So for that, we need to first begin with the, like we need to do it in steps, right? So the first thing which we need to do is we need to go to our build.gradle inside the application and there are dependencies noted over here. So we need to add three dependencies over here. The first one is the Mossy, which I'm pretty sure it's shown in the PPT. The Mossy it's used for converting the JSON objects into Kotlin objects. After that, we'll be using retrofit with Mossy converter. So we need to include that in a dependency. Retrofit would be connecting with the backend, and Mossy would be converting the JSON objects into Kotlin objects. So for that, we need to make sure that we include that in the dependency. And then we need a coil, since we'll be getting the data of the image, not in the form of an image, not in like JPEG or stuff, right? We'll be actually getting it in the form of URL. So we need to download it and just then display it to the user. So we'll be also including the dependency of coil. So these are the three dependencies which you would be needing in this code. If you also use a different library, like there are other third-party open source libraries like Volley and stuff. However, Retrofit provides us with the most fastest response, so we are using Retrofit. So even if you use some other like library, you also need to include the dependencies over here. After including the dependencies, the thing that you need to do is you need to go into your Android manifest.xml file, and over here you need to give the permission to pass like access the internet. After accessing the internet is important because since you're connecting to the internet and like we can't expect the user to be very tech savvy, right? So it might happen that the app like the application might connect to the internet for some other shady purposes. So it's not provided by default in the manifest files. So we need to add this line of code like uses the permission Android name, Android permission or internet. It's like if you install a new app, you might have seen things like, do you want to give this app file permissions or do you want to give this app permissions for audio and video and stuff? It's kind of like that thing. We need to provide the permission to for the app to access the internet. After this two stuff is done, which is like the first things you need to make sure before you make an app which connects to the internet, then we move on to the first part, which you have here. And over here, like you can see, these are the import libraries which have been imported. Now, although you'll be getting automatic imports inside the Android Studio, it's important that you know what are the things you're importing here. So the first thing we are importing is Mossy because we need the Mossy library for, like I said, for converting the JSON objects. Then we are importing Kotlin along with the Kotlin to JSON converter of the part of the Mossy library. We are importing Retrofit. The current version of Retrofit which is being used is Retrofit 2. So we are importing Retrofit 2.retrofit. After that, we have the retrofit to Mossy converter factory, since retrofit would be actually connecting to the backend, and Mossy is the person is like the library is converting the JSON objects to Kotlin objects. So we need to make sure that the retrofit converter with the Mossy is also imported. And like I said, we'll be just fetching the data over here, right? We'll not be doing anything like posting something or stuff. We just get a series of images from a website and then we're displaying it to the user. And since you'll be using a recycler view, but you have already studied in the previous courses, so I won't be getting into that. So we'll be importing the get part of the retrofit library. Okay, so after that, the first thing that you need to make sure is the base URL. This is the URL from which we'll be getting the data. Like it could be like suppose if you're getting some search from the like Google search engine, so we'll be passing like www.google.com, right? HTTP is like the protocol which is being used. It would be HTTP is www.google.com, like that. So over here, since you are fetching this from this server of Android Kotlin fun mars server.export.com, we need to pass this as a base URL. After that, we'll be creating a Mossy object, which is first we'll be calling the Mossy.builder function. After that, we'll be making sure that since we are using the Mossy's JSON to Kotlin converter, so we also need to call this function. After that, we'll be just building it. Then we need to make a retrofit builder. A retrofit builder for that, similar to Mossy builder, we need to call the retrofit.builder. Then we need to add the converter factory function call because we need to convert it into Mossy. And here we'll be passing the Mossy object that we have been created here. Since we need it for the retrofit library to know that which part of it is converting the JSON object. Then we'll also be passing a base URL which you have made over here because we need to know like from which server we are getting it, and then we'll just build it. So like you can see the difference between Mossy and retrofit. Like in Mossy we're just creating the Mossy object and then we'll be using it actually later on. But in the retrofit part, we are passing the Mossy object which we have created. We are also passing the base URL. This is the retrofit library is the one which is going to do most of the work over here. Then we have a public interface to get the get photos method. Now, retrofit library provides us with a thing called interface. Interface is used to get the data. Like it doesn't have to be get the data. It could be like if you're getting some data from the server, also like for post and stuff. If you're getting something, it we can use that for those purposes. Also the interface. So over here, the name we have given as Mars API service. You can just provide any other name. Since I told you like we'll be getting more than one image, right? We'll be getting an array of image actually. Here we are using a list, which is pretty similar to an array. So we'll be getting a list of images. So we are making sure we call it using a list. And this is a function call, which is a suspend function call. And like I told you, since it's a networking call, we need to make sure that we use the coroutines over here because without the coroutines, since it might happen that your server is slow or your network is working slow, so the app might get laggy, right? We don't want that. So we need to make sure that it works, the call is made using a coroutine. And so we are using a suspend function. The function is defined in a separate Kotlin file, which I'll be going into. And other than that, we are using the get method over here. And what is the photos part? The photos part is the endpoint, like just the server name, and at the end of the bracket, this photos endpoint would be there. So it would know like from where to get those photos. So it would be like instead of photos, it would be like some audio and stuff. So it would be like after slashes audio. Here we don't have any audios and stuff, but if you're using some different search server to get the data, it might happen that in case instead of photos, you might want something else. So we'd be using a different endpoint over there. After that, we'll be doing the suspend function call. And at the last, we need to make an object, which is defined by lazy. So it's like it needs to be initialized the first time we are doing it. And then we'll be creating the Mars API service class.java, which is basically it's calling the interface over here. So after that, moving on, we'll be having Mars photo.kt. Over here, like I told you, we'd be getting the JSON response. But JSON response, like I showed you in the PPT, it's an array of JSON objects, and it's in the form of ID and keys and values, right? So over here, we need to create a data class which is gonna receive the JSON actually. So you can see over here we have imported the mostly.json, and for the ID, since ID in the form of string, so it will string, and the other parameter which would be having in the JSON response is img underscore src, which is like the image source, but it's like in short form. So we need to get the JSON image, and since we'll be using the images, so we are putting it inside the img src URL, which is a string. This basically does that. It receives the JSON response using this data class. Then we need to moving on to the overview fragment. Yeah, sorry. In the overview fragment, we are actually inflating the fragment, like which is going to display the app. So like you might have used this in previous classes and stuff. And then we need to bind it. So like binding also you might have used before. Since it's a live data, since you're like every time if you're refreshing the page, it's getting the responses on the internet. So it's doing a live data with the life cycle of the fragment. And it's also accessing it to the overview view model. If you might have listened to the last part where there was a bit told about the view model. So the binding for the view model, and then it's just setting the adapter to the recycler view. So if I have this code over here, the photo grid adapter, it's basically the code for recycler view. So overview fragment is making sure that we are getting the photos and then we're displaying it to the user to the recycler view. After that, we'll be calling the overview view model. And over here, the lot of function is being done. Remember, we called the get Mars photos from the Mars API service.get. Yeah, so we're calling the suspend function, which is being actually called in the overview view model.kt. So over here, the get Mars function for a get Mars photos function is getting the data from the internet, and we're using the retrofit service.get photos. Like over there in the retrofit, we had already mentioned our endpoint photos, and we are passing it in the server, right? Now, like I was telling you about in exception handling, that it might happen that you might not get the internet, or it might happen that the server is down and stuff. So we are passing these codes in the try block. And in case it doesn't happen, then it's catching the exception and it's gonna display that error, right? And the value is gonna be an empty list, right? So, but in case it works, it's gonna keep the responses done. This is exactly what's happening, and we are just putting it inside the view model. Other than that, over here we are calling the API statuses. Like we are calling over here API status done dot error. So that's what's being done here. The view model is attached to the overview fragment. Like we have different fragments. Over here we use the overview fragment, and the status variable over here is storing the status of the recent request. Like if you are requesting and if you are getting an error code, so it's gonna store it as error. If you are requesting and if it's loading, it's just gonna store the status of the current request. Then we are changing the status of the depending upon the live data which we are receiving, and we are using a mutable live data because like we'll be updating the list of the photos every time we get new photos, right? So if you like scroll up and down, we'll be getting a new set of images and stuff. So for that, we need to use val, and we are using a mutable live data. And the external live data interface to the property is immutable, so we need to add another photos. This is different from this one though. So over here, we are just getting the data from the Mars photos and storing it over here. And we are calling it as an init so that we can like display it immediately. And then this function call is being made over there. Other than that, we are going into the photo grid director. Like I said, we are just like the recycler view code you can see, and like you can understand it's basically using for the recycler view. It's taking the images, like we're getting one images from the internet and it's displaying to the user to the recycler view. And then the last thing is we need to bind the stuff, right? So we need to make sure that the images which we received are getting displayed to the user using the proper binding adapters. So like we need to make function bind recycler view, which is getting the list of my or like Mars photo images, and then it's passing it to the like for the recycler adapter we are using the photo grid adapter code, and then it's just passing it to data. And remember I told you about the coil library. Like what the coil library does is the image is not being received in the form of a like JPEG format or like whatever format it is, JPG and stuff. It's getting the images being received through the way of a URL, right? So we need a coil library to load the image by URL into the form of image view so that we can display to the user. We can't display the URL to the user, so we need to make sure that we download the image and then we display it to the user. So over here in this function, the bind image, we are just receiving the like string, and then we are making sure that we convert it and we are turning it into drawable. Like drawable is where the images are stored and stuff. So inside that, we are just checking it and storing the images. And in case if the image is not being able to receive due to some reasons, we have the error edge cases noted over here. So then we'll be displaying a broken image. So if you like go into rest and if you go into drawable, you see that we have different things available for like broken images and stuff. In case if the image is not accessible, so it will be displaying this. So okay, yeah. So other than that, then we go down and then we are calling the Mars API status. This would actually like display the status of the network request which you are receiving. So like if you are loading, like I said, if the suppose when you make the request, if you have seen over there in the overview fragment, sorry, in overview model.kt, yeah. So see you can have the different we are loading, we have error, and we have done. So it needs to display the images based upon that, right? So if you go into binding adapters, so it's receiving the status, and if it's like loading, it's gonna display as the loading animation. If it's an error, then it will be displayed as the error connection error and images of that, of depending on what the status is actually receiving. And if it's done, like if the proper response is getting received, then it would just displace to the image. And in the main activity, nothing is basically being done except for the main thing which is being created. So like if I run the overall code now, I need to change this. Yeah. Yeah. So if I run the code, you'll see how exactly the thing is working. The boilerplate of the recycler view code and this app image and stuff is already done. It's just the internet part which I'm showing, like how to connect to the internet and stuff. Like if you have followed, it doesn't have to be recycler view also. If you just want to receive one image, you can totally skip the recycler view part. You can just place an image view holder and just display the one image that you want to display to the user. So whatever it is, if it doesn't have to be an image, you want to like display it could be like a quote or a tweet or anything that you want to display. You can just display it using a text view, edit text and stuff. Yeah, so you can see how through the cycle view we are getting the images and it's like displaying them one by one. And since it's loading over here, so it's showing us the loading images animation. And if like I'll show you if we put the airplane mode on and then if we try to run the app again, we just need to cancel this. Yeah. So if we now try to run the app, it's not going to be able to connect to the internet. Actually, it's connecting to the internet over here because since previous data is already stored here. But if you like try to do it the first time without being connected to the internet, you'll see that it can't be connected to the internet, and it will show you over here the binary address. Yeah, it will show you there's a connection error, and it will show you this.
Excuse me, bhaiya. I think you should turn off the Wi-Fi and then work.
Uh, Turn off the Wi-Fi. Acha, it was connected
Yeah,
to Wi-Fi, right? Yeah, sorry.
yeah.
That's what I'm doing. Yeah, one sec. Oh, right, sorry. Yeah, so if I close it again and if I start it, it's not supposed to work now. No, see, like I told you, no, it's already receiving the data.
The
So,
aeroplane mode is off now, I guess.
okay. Oh, this
Turn
emulator
off the
says for
mobile
like,
data.
yeah, wait. Yep, and it's supposed to work now then. Yeah, fine, thanks. So this is the thing. So if you turn off the complete internet access, it's gonna display us the error image because it's not being able to receive the status response, and it would actually be receiving the status response using over here. It would be retrieving error response. So because of that, it would be displaying us the connection error driver, which is over here. So, and if you just then again switch off the airplane mode or like turn on the Wi-Fi and then display it, it's gonna work perfectly fine. So if you just turn it off and then again restart it, so it's gonna work now. Yeah, so it's working perfectly now. So this is it. Does any of you have any questions? No questions. All right. Um, so this is it. Like this is how the coroutines and connecting to the internet works. Like I said, it doesn't have to be recycler. It doesn't have to be Mars image. It could be any simple thing. So there's an API, and we are also we are calling it using the REST framework over here, like using the get method. So like any kind of thing, if you want to connect to internet, suppose you want to make something which is going to display the tweets of some kind of a Twitter account and stuff like that. So you just need to make a API call to a Twitter. You'll find that in the developer format of any good websites. You'll find that there are APIs available, public APIs which can be used. So we can just make those API calls and then display it using a simple thing also. It doesn't have to be a recycler view or any scroll view or any kind of views. It could be just like a simple layout. We are just displaying a simple thing. So this is it. And so other than that, after this, we'll be having the future proceedings. In the next part of it, we'll be having the room database. It is actually on December 29th and it will be taken by Aditya. Other than that, you guys need to make sure that you complete your developer profile badges and you guys need to submit it over here. The last date of submission is 8 January. So has any of you completed till unit 4? Till yeah. Or unit 1, 2, 3? No. Nobody's doing the units over. Like you guys write in the ASJ discuss, right? You guys have completed a few.
I've completed 1, 2, 3, I guess.
Yeah, right. So you make sure you submit the like the badges before 8 January 2022 and like
Yeah,
complete
I
it till
also
the end.
completed.
Huh,
Unit 4 is left.
yeah, that's all right. So you need to complete it and yeah, this is the badges link which is being provided. So you need to make sure that you guys submit your developer badges over there. And to all the units completed, like it's shown over here, you guys have last date till 8 January, which is a long time, so you guys can comfortably complete it. And this is a public Discord server, which I'm assuming you guys might have already been now, right now. So that's none of you have any questions. And just feel free to ask. You can also ask me later on in the Discord if you want. That's all right. While working on the code, if you want to ask something. No questions then still. All right then. That's it. This is in your Android developer course pathway. You just need to like do the coroutines and connect to the internet HTTP batch over there. So does anybody want to ask anything other than this, like regarding this stuff?